Thanks everybody for coming. This is the next in our series of DevOps for SysOps. If you guys have been to some of our previous ones, most of those were done by Daniel, who's on our staff. The goal behind this series is, like it says, it's really DevOps principles for those of us in the system administration world. Maybe you're interested in infrastructure as code. Maybe you're interested in things like Ansible or other technologies to automate some of your day-to-day tasks. You didn't know where to start. I think we've all been there. I know these are questions that we get asked a lot from on our consulting side. So we decided to start with some. These are all introductory topics, right? So if you're a seasoned pro in DevOps, this is going to be very 101 type work. Um, so if you're interested, these are all build off each other. You don't have to have seen the previous ones, but we start with introduction to Git and we work our way up from there, talking about different principles and how you can apply them in your organization to get to more of a what we're starting to see is a more of a code focused infrastructure model, right? So we're looking to get into infrastructure configuration as code, doing things systematically instead of point and clicking. We're gonna do code reviews. We're gonna push all these changes out and have the ability to roll back and know what we did because the code is our documentation. Today we have a new player in the game for us. We have Ben Heinze. Ben's with us a couple of years. He's a relatively new grad, but he has seen a lot in the last couple of years working for us. So these guys, I kind of call my office of special projects. If you have some complicated problem that you don't even know how to get these systems to talk, if it has an API, we can pretty much get those things to talk. We see this a lot around different backup technologies, automation, self-service. So these guys are doing this every day from a system administrator point of view, which I think is important. This is really, like I said, not the seasoned DevOps developer role. These are those of us who are doing the day-to-day administration, backups, configuration, building systems, virtualization, cloud-based technologies. Maybe we've started working with some other those technologies and like really want to start expanding our portfolio. So
All righty. Thank you, Fred. So, like Fred said, my name's Ben Hines. I'm on the DevOps team here at WEI. And again, we're building off of our DevOps for SysOps series and some of the configuration as code talks that Dan has given. So, just as a quick recap to start, um, we're all admins, right? And we all have various platforms that we manage. Maybe it's VM workloads on our private cloud, or maybe we have VMs in the public cloud, or really anything running in the public cloud, microservices, containers, you name it. Perhaps we're on the network team or a security team, and we have to manage our network infrastructure or security infrastructure. And maybe we have some sort of Kubernetes platform that we manage to run our containerized applications. So it can be a headache if we're going out and working with each of these platforms on their own, logging into GUIs and manually managing. But if we use configuration as code, then we as admins can just interact with that code file, with that configuration as code tool, whatever it is. And from there, that tool can go out and interact with all these applications. And it gives us a number of benefits, right? Once we have that file, whatever, for whatever tool it is made, we're just clicking run, right? So it's super fast to deploy at large scales. Also, we're not going through a GUI and filling in fields, so there's no fat fingering. There's no messing up a click or a copy and paste. So we can eliminate those human errors and get rid of mistakes. And then Fred touched on this a little bit earlier, but it's code, right? So we can check it into source code and get those configuration as code benefits like versioning and rollback that Dan has covered in depth in previous sessions. And again, if you haven't seen those, I encourage you to go check them out, but maybe wait till after this one. Um, all right. So in this case, as I'm sure you've seen by the title, our we're going to use Python as our configuration as code tool, right? And with Python, it uses APIs. And don't worry, we'll define all this in a few minutes. Um, but all these platforms have APIs. So we can use Python to interact with anything. So say we have a workflow where we want to deploy VMs to both our private and public clouds, right? So a workflow that spans those two pieces of infrastructure. Or we need to get our local network to talk to the clouds. Or maybe our containerized applications need to talk to other servers on our corporate network, right? Because Python can talk to everything. It allows us to create those integrations and share data amongst different apps and platforms. So there's one benefit of using Python where it might fit in. Um, Now, as admins, we've all had days where, we've got a headache, we've got steam coming out of our ears because we just have a really hard configuration task that we have to deal with, right? Maybe we have to go into a few platforms and clean up stale data, but we need to be really careful because we don't want to touch anything in production, right? It's, one of those extra cup of coffees or maybe extra 2 cups of coffee type days. We've all been there. But let's say we use Python and we've automated that task, right? So now we interact, we run our Python script, and Python goes out and does the cleanup and takes care of all that for us. Well, now we're just clicking run. So maybe the steam stops coming out of our ears, and our headache might go away, right? Because we've simplified it down to clicking a button. And because, so why Python here? Well, Python allows us to get very specific and very detailed in our configuration, so we can handle those complex tasks, right? And because it can get so detailed, we can be extremely accurate while we do it. So there are some benefits. What we'll do here is we'll dive into a little bit of API background, right? We're going to be talking about Python almost entirely in the context of APIs. From there, we'll give a little bit of info on Python, some benefits around it, and then we'll talk about a bunch of use cases and follow that up with demos on almost all those use cases at the end. So let's dive into some API background. And so I work with this stuff every day, and I can hardly remember some of the acronyms. So I'm going to try and define everything for you, I know it would preserve my sanity if I was sitting there listening. So if you know this stuff, bear with me. If not, that's why I'm trying to define. So first off, GUI or GUI. It's a graphical user interface. We 9 times out of 10 use GUIs to interact with applications, right? We're pointing and clicking, filling in fields. It's what we're all used to. An API, on the other hand, is an application programming interface, right? This allows us to interact with those applications, platforms, you name it, using code, right? Using a program. And it's doing the exact same thing a GUI is doing, right? So this Python script on the right does the same thing as clicking through that GUI on the left. Oftentimes, GUIs just provide a graphical way to call APIs. So what we're doing is, instead of using the GUI to call APIs, we're now programmatically calling them. And so when we talk about APIs, right, a lot of the configuration as code tools that we've touched on and that we've heard of use these under the hood, right? Tools like Terraform and Ansible provide wrappers around APIs where you just pass a few key values in, and they handle that API call. So because we're doing pretty much the same thing with Python, we're going to add Python to that list of our configuration as code tools. So in past sessions, Dan has talked about Terraform and Ansible. So I want to touch briefly on kind of where does Python fit into this, in with the tools that we've already touched on. So Terraform, and I'm kind of painting in broad strokes here, but Terraform is great for infrastructure deployment, right? Whereas Ansible might lean towards configuration customization. Again, they're not completely siloed. There's a fair bit of overlap there, but just at a high level. And then with Python, we can do infrastructure deployment, we can do configuration customization, and we can really do anything, right? And that's because Python's a programming language, right? There are many apps coded in Python. Instagram uses a ton of Python. YouTube uses a ton of Python. Ansible core is actually coded in Python, right? So you can build almost anything in Ansible. So it allows you to get super detailed and create that custom configuration. Whereas tools like Ansible and Terraform, you're using pre-built automation and plugging in values, and you're leveraging that pre-built aspect. So think of Python kind of like a blank canvas, whereas Ansible and Terraform might be a bit more like painting by numbers. And I think it's an important point to note that sometimes if you're painting by numbers, you can get there quicker often. But again, you might not get exactly what you need. So that's where we kind of see Python fitting in. All right. So now we'll get into Python a little bit. So first off, kind of why Python? Um, One of the main reasons I really like Python is the syntax is pretty straightforward. You don't know it's it's very close to English, I'd even say. Like if I read this code for item in list, print the item. It's not terribly hard to see what that little block of code is doing. We're going to go through each item in the list one by one, and we're going to print it out. If value is not none, append the value to the list. Like this is very close to plain English, but again, it's valid Python code. Um, so say we as admins want to try our hand at a little Python scripting. I'd said earlier it can be a blank canvas. And as someone, if we stick with that analogy, I'm terrible at art. If I see a blank canvas, I'm getting worried. Um, but in this case, we can pull in some numbers to paint by numbers in the form of libraries. So libraries are collections of pre-written code, pre-written Python code. Um, within each book in the library is called a module in this case. We'll see that term come up. Um, but it allows us to leverage pre-built, often by vendors, pre-built code that now it'll almost work in some cases like Ansible or Terraform, where we're just plugging in certain values. And so we don't have to build everything from scratch, is kind of the point of this. Um, Built-in JSON handling. So JSON is JavaScript object notation. It's a very common data format. To pass data used to pass data in API calls, right? If we're doing something like deploying a VM in Nutanix, well, Nutanix needs to know what's the name of the VM, how many CPUs, memory, disk size, all those variables we put in and all those values we put in when we click through that GUI, they're still needed when we go through and do it programmatically through an API. So JSON is often that data format that we use. And we have to make sure that it's formatted correctly. And it can be a nightmare if we have a big block of code, like you can see here, to go through and do that. But with Python, there's built-in JSON modules that will go and parse through it and get that format accurate for you. So it's a nice feature. Similar to the JSON bit, I guess is in life and with the different platforms we interact with as admins, we have a number of ways that we authenticate. Maybe it's a passkey, some sort of biometric, a badge, a token, username and password, you name it, right? APIs are the same way. There are a whole bunch of ways that we authenticate when we make API calls. And again, going back to those powerful libraries and built-in features of Python, Python can handle nearly any form of authentication. I have yet to find one that it can't handle. Um, so again, it makes that bit simple. One little note: don't store a password in plain text in your code. I've done that. It's a terrible idea. Sorry, a little sidetrack there, but yeah, don't do that. Python can run anywhere, right? We can run on Windows or various Linux distributions, Mac, Unix, you name it, right? Why that is important is it makes our scripts portable, right? We don't have one server that we can run these from. We can run them from wherever, whenever we need to. All right, now let's say we have a workflow, right? we want to add a subnet to our corporate network, and we're going to register it on info blocks so we can track our IP usage and see what's available. And from there, we want to deploy VMs to it on Nutanix. And those VMs need to interact with some service in AWS or something like that. Well, because we're using Python, we can talk to all these. So, like one of those complex multi-platform workflows, Python can reach out and can handle automating those. And because it can talk to everything, if we want to, we can even use Python as a single tool, um, as almost a single pane of glass to interact with all these platforms and applications. So now going back to kind of that blank canvas idea, right? We're gonna go try our hand at a Python script. Um, it can be daunting, right? But there are tools out there to help. So IDEs, integrated development environments, got that one right. Can never remember that. Um, they provide a good platform to write our code on, right? They offer a set of helpful tools like over Visual Studio Code is an example that I'm using here. And on the screenshot on the left, we can see little vertical lines going down that shows indentation, right? Indentation is extremely important in Python. So the lines like that showing that you have it right, how far everything's indented can be extremely helpful. Same with color coding, right? Integers are kind of that green color, where a string is orange and a variable is light blue in this. So IDEs like Visual Studio Code can be extremely helpful when we're getting going. AI is also really good at Python, right? ChatGPT is a free Python specially trained model um, that you can go out there and use. It where AI where I see AI kind of fitting in is it can get you in the ballpark, right? It can help you get started. It can give you a base to work from that you might have to then go in and fine tune your script to really get it functioning properly. Or maybe you have a typo, right? Maybe you have an extra space somewhere and your indentation is thrown off and you've spent 6 hours looking at this code and just can't find it. Well, AI is pretty good at finding that stuff too. So there are tools out there that can help you get the ball rolling and help you get going if you decide to go down this route. So on top of that, um, it's useful to know um, how do we what data do we need to pass in an API call and where do we find that? So there's a ton of good documentation out there, often supplied by vendors, um, almost always supplied by vendors on APIs. So this is a screenshot of Nutanix's API documentation. It's called Swagger. You can see each of those boxes is its own API, and so we can click into them and expand them. So here we expand the create a new VM API, and we can see the different fields it calls for. We have to pass those specs in, again, like name, the resources it needs, such as CPUs, memory, disk size, an image to clone from, maybe network adapters, that kind of stuff. And that data makes up that body. The body, yeah, the body of an API request is where we package that data. And I'll highlight this in some code as we get into the demos down the line. But the point here is that there's readily available documentation and information out there. Okay, so we'll switch gears slightly and we'll talk a little bit about some workflows. What do some of the workflows of these scripts look like? So this first one, we're going to use Python to deploy a VM on Nutanix. And this is something we've done for a customer, for a large pharmaceutical company. They came to us looking for a script to deploy VMs to Nutanix, and they needed to be configured properly. So they had agents installed, they had the proper security settings, they needed an IP and to be joined to the domain, right? A whole bunch of things, a whole bunch of boxes that we needed to check. And so with this example, we're kind of looking at a base case of that, but this is something we've done. So at the base level, just deploying a VM. Well, the step one, we create that body for the VM creation request, right? We get the necessary data together. Once we have that data together, we send off that API call to tell Nutanix to create a VM, right? That's kind of the base case, a pretty straightforward workflow. And this is the exact same thing we're doing when we click through that GUI on Nutanix, right? It's the equivalent. Now we're just doing it in Python and doing it programmatically. Okay, let's step it up a notch here. So in this case, you'll see we're gonna string together a couple API calls. And why? Well, we want to mirror the configuration of interface one on this switch to interface two. So what does this workflow look like? Step one, we fire off an API call to pull in that configuration for interface one. So we're not always pushing out or sending a configuration. We can also pull data with APIs. That's one important note. And then once we pull that information in, we're going to parse through that response and process it with Python to pull out the important bits of the configuration. And from there, we'll send another API call to push out the configuration of interface two. So you can see here, we're starting to string together API calls. Now let's say we want to define our configuration of a whole bunch of interfaces in a CSV file, right? We have the format of our CSV file here on the left. And it doesn't have to be 3 lines. It can be n number of lines. So we can define one interface here. We can define all the interfaces here. And with Python, what we can do is we can go and we can read the CSV and loop through line by line. And so for each line of that file, we can send off an API call to configure an interface, right? So this allows us to define whatever it is in a standardized format and boom, push it out with the click of a button. And this is also something we did for that pharmaceutical company with that script, right? They define their VMs, all the specs, the size of each disk, how many CPUs, how much memory, IP, network, where it lives in Active Directory. They defined all that in a CSV and from there they could just point the Python script at that CSV. It would read through and deploy however many VMs were defined in there. So it allows for a lot of efficiency that way. All right, so we talked about libraries. I just want to compare what it looks like to script out an API call with and without a vendor supported module. So, and remember, a module is just one piece of code in those libraries. It's a book, if you will. So first, what does it look like without a vendor supported module? So in this case, let's say we're interacting with AWS. So our main script, first, we have to get that body together, that key data. And oftentimes there's going to be some supplementary data that we also have to fill in. That's less important. Then we have to get our headers together. Our headers contain information on what's the data format of the body? How are we authenticating? What are your credentials? That kind of stuff. That's key information and needed for the API. And with the body and the headers, one important note is the format is often very strict, right? So we have to make sure we match and are accurate with our formatting here, or else we could break something or the API call won't be processed. Once we have that together, we can then send off that API. So it's not terribly hard. It's not a crazy process, but again, we have to be super careful that we get that formatting right. Now let's compare that to if we use a vendor supported module. So this time we still have our main script and we're still interacting with AWS, but we're going to import a module and put it in the middle. So what does this look like? From our main script, we pass those few key values into that module. And from there, the module just sends off that API call to interact with the application. So the module kind of handles that nitty-gritty stuff of getting our headers and our authentication and whatnot put together, and makes it pretty straightforward to fire off those API calls. We just need, again, if it's a VM, we just need the name, the instance type, and size in AWS lingo. So we talked a little bit about how Python is used in various applications, and it's used everywhere, right? So a lot of platforms have Python or orchestrators. And what an orchestrator will do is it will run your code for you. So now if some sort of event or some sort of criteria is met, it will kick off that code and it can take you out of the loop, right? You can even, with a platform like ServiceNow, for instance, you can create self-service using an orchestrator. So let's look at a little bit of what that might look like. So in this case, where we want to create self-service for allocating static IPs and creating DNS records in info blocks using ServiceNow. And if you're coming from the info block side, you probably know what it takes to go allocate a static IP and create a forward and reverse lookup record in info blocks. It's not that bad. I don't know, maybe 15, 20 minutes. You want to be careful. You want to get it right. So you take your time. But Infoblox is a great platform, makes it easy to go and do that. The issue is if you're head down working at a higher level task, you're really grinding away, flowing through it, making a lot of progress. And then you see that email come through or you see that ticket pop up. Now you got to stop. You got to go log into Infoblox, make sure that person is authorized to receive that static IP. Go get them the static IP, do all that, get it back to them. But now you've lost your train of thought in that higher level task, right? So you got to go retrace your steps, maybe rerun through a couple tests. Um, this is at least what it would be like for me. And by the time you're actually back on pace, I don't know, maybe you lost an hour or maybe a little more than an hour, maybe slightly less, but you've lost more than the 15 minutes it takes because you got to get back on track. Um, the same goes for the person requesting that static IP, right? The Infoblox admin probably isn't going to see that email or that request immediately. So they're making progress and we need this server to keep going and keep working on whatever it is we're working on. Well, they're sitting there waiting for an hour, 2 hours, however long it takes. So from whichever side, we're losing an hour if we're kind of waiting on this script to be run manually or waiting on the process to be done manually. But now, if we go through this workflow, if we use ServiceNow to orchestrate our Python script to create those records and allocate a static IP, it looks kind of like this. The person who needs it creates a ticket. ServiceNow will initiate that script to go get those static IPs. The script will send off an API call to Infoblox. I need a static IP. Infoblox will return that static IP, and then Python will return it back to ServiceNow and that user. So now we free up time on the Infoblox admin side of things, right? We don't have to go in and do that manual process. And from the person requesting the static IP's point of view, that script gets run right away. So it's a matter of minutes, if not seconds, until they get that back. So again, creating self-service around that is where those orchestration platforms can really shine. And all right, one last workflow here before we get into demos. So we talked about integrating applications. So in this case, we want to deploy a Nutanix VM with a static IP from Infoblox, right? So what does a workflow involving two platforms look like? Well, step one, we'd send out an API call to get that static IP from Infoblox and create those DNS records. Next, we pull the IP out of that response from Infoblox, and we fire off an API call to create a VM with that static IP on Nutanix, right? So it's not anything crazy, but there is a better way we can do this because we've already built those scripts, right? So we can instead leverage the work we've already done to build those scripts, and we can just call that get static IP script for info blocks and plug that IP that we get from that script into our deploy VM script from Nutanix, right? So if we build these out the right way, we can almost use them like Legos, if you will, and mix and match and plug them in together and whatnot. So just taking a breath here, this is the same stuff. These are the same workflows we'd be going in and doing in the GUI, right? We can go in and create a reservation, allocate a static IP, create DNS records, and then go and create a VM with that IP in Nutanix. Or we can do the exact same thing programmatically with API calls. All right, so now we'll get into a few of the demos. And we'll move through these fairly quick. I'll highlight some stuff. I'll show some screenshots of the scripts, and I'll highlight important bits. Um, and these demos are pretty much all the same as the workflows we just discussed. So again, this is our base case, just creating a VM on Nutanix. So here's most of that script, and I'll highlight some important parts. So up here are kind of the authentication bits. We have our username. We're prompting for username and password. Again, we're not storing the password as plain text, and we're hiding it when they enter it. Our headers, right? We can see that we're passing in our data as JSON, our content type, the base URL of where to send our HTTP request, our API request. Next, this block makes up the body. That's the data that we're sending over. We'll highlight a small part of it because it's a somewhat large block. But we can see here it includes values like the name, memory, CPUs, disk size, and an image to clone from, right? It's the same stuff we'd specify as we click through that GUI in Nutanix. And so then taking those two pieces, the headers and authentication bit in that body, what we do is we'll plug them in to our request. So our authorization, our credentials go in under the auth section. Our headers get plugged in as headers. Our base URL gets turned into our URL. And from there, our body goes into that data section as that payload. So if we see this in action, we'll start here in our Nutanix GUI. We'll come back to this is Visual Studio Code. We'll run the script. It'll prompt for credentials. And we can see that VM creation request was sent. And now if we go back to Nutanix, give it a refresh, and we can see that VM was created. We click into it. We can see the specs we gave it. Again, we didn't have to type anything in, so it's created with the exact specs we were aiming for. All right, on to the next one. Again, I'm gonna move through these pretty quick because I got a bunch of them to talk through. So this one is we're mirroring configurations from interface 1 to interface 2. So here's the script, a bit longer. But remember when we talked through that workflow, we talked about stringing together multiple API calls. So here we can see each of these send RPC lines is another API call. So we actually string together 5 in this script. RPC stands for, let's see if I can remember this one, remote procedure call, right? It's just the type of API. It's more geared towards, rather than pushing out a configuration, it's saying we want to call these functions of whatever product or application. So in this case, we have 5 calls. This first one, we fetch the configuration for our source interface, interface 1. Next, we want to lock the configuration of the switch while we make our changes. The third one is actually pushing out that configuration to make the change. The fourth call commits the change, and the fifth call unlocks that configuration once we're done. So if we go and if we see this in action, first we'll look and we'll check on the configuration of interface 1. We can see it's got the description, access VLAN 100, it's in mode access, and it's a member of VLAN 100. And we can see here that the configuration of interface 2, it's not configured, right? And there we're specifying our source and target interface. And we'll kick off our script to mirror the configuration. So we can see there that we pulled down that configuration from interface 1 and we've listed it out. Now we're going to push those changes out and commit them to interface 2. And we can see that we successfully cloned that configuration. And if we go back to our PuTTY session to where we're SSH'd into the switch, we can see that that configuration for interface 2 has now been updated to match interface 1. All right. Moving through these, this is where we're looping through that CSV. So here's the script. We'll highlight a few parts. Here, we're importing those built-in modules. The CSV one is the relevant one in this case, right? That allows us to parse through and loop through that CSV file pretty easily. Next, we're going to specify the CSV file, where it lives, which one we want to read. And then down here, we're going to loop through it, right? So for each line, each item in that CSV file, we're going to use that dictionary reader function of the CSV module to open our CSV file and read through it. And for every line in there, we're going to configure the interface specified in that line with the proper mode in VLAN. So if we see that in action, I'll go back. This is the exact CSV file we're going to use. So I'll go through interfaces 3, 4, and 5 to show you that configuration before we run the script. So again, showing the configuration for interface 3, we can see that none of them are configured. They're just in default. All right, so we list all of them out on our PuTTY session. Now we'll run that script. We'll provide credentials. And what we can see is we're sending out configuration to interfaces 3. Right now, it's going to commit the changes. Now we're on to interface 4. Again, it'll take a moment to commit those changes. And now we're on to interface 5. And once this is committed, we'll go back to our PuTTY session and we'll check on those configurations and see if they match what we specified in our CSV. So now if we rerun the show interfaces command, we can see that interface 5 is in VLAN 103 and is in access mode. Same with 4, but it's in VLAN 102. And now for 3, we're in VLAN 101. And we've set that description for each of them, right? So we're looping through that CSV. And that could be, it was 3 interfaces in this case, it could be 20. It's whatever number you want, however many are specified in that CSV. So Now, using Bodo 3 to deploy an EC2 instance. So Bodo 3 is just the name of the AWS Python library. So we're going to import the EC2 module from that Bodo 3 library, and we'll use that to interact with AWS and to deploy an EC2 instance. So here's a snippet of the code there. So you can see at the top, we're importing Bodo 3. Then we're going to specify our key values, right? Some are just global defaults, some are specific to the EC2 instance we're going to launch. Like, so region would be a global default. AMI ID is the Amazon machine image that of whatever VM we're going to deploy. And from here, we just use a function of that EC2 module to send off a request to create that EC2 instance, right? And what we can see is we are just passing in those key values here, right? So AMI that we specified above gets mapped in there, instance type gets mapped, our subnet gets mapped, the private IP we want to give it gets mapped, and our key name, right? So we don't have to handle that formatting of the headers and the body and whatnot. We're just passing in those key values. So let's see that in action. We'll start here looking at the script, scroll through it quick, right? We're just sending in those key values. If we go to AWS, this shows our running instances. There's nothing there. So now if we run this script, boom, we launch that EC2 instance with that instance ID, and we can see that the name is going to be API demo EC2 instance. And so what we'll do is we'll go back to AWS, and we'll give it a refresh. It has to get to a running state here, so we'll give it a second, and then we'll refresh again, and we should see that instance come up. Yep, there it is. And boom, API demo EC2 instance. All right. So moving on to the next one. In this case, we're going to be allocating static IPs from Infoblox IPAM. We didn't include ServiceNow in this. It's a little outside the scope of the demos, but we wanted to include the Infoblox portion. So we'll look at that, right? We'll get our static IP, and then we'll send out an API call to create DNS records for that static IP. So in this case, there's not a whole lot new in this script that we haven't touched upon, but what I want to highlight here is we're going to prompt the user for input. So we'll have the user enter the network they want the IP on, the CIDR block of that network, a fully qualified domain for the DNS records, and then to keep our lab clean where I'm deploying this VM, we want to specify initials of the owner and a workload that this is for, so we can track down who's using it and what for. So if we go and we'll see this in action, this is the Infoblox portal. And on this 10.11.89.0 subnet, we're going to get the next available IP, which we can see that 0 to 10 is taken, which leaves 11. So now if we go to Visual Studio Code and run our script, we can see that we're being prompted for that network, for the CIDR block, and for our fully qualified domain name. And then initials and workload. And once we enter all that, it will send out those API calls, and boom, we've created an A record, a pointer record, and it returns our IP that we can then go out and use. Now, if we go back to Infoblox, give it a refresh, we should see that IP up there. And there it is. And we can see that the A and pointer records were created. All right, so last one here. I know we've ripped through a lot and we've gone pretty quick, but this is where we're referencing our previously built scripts, right? We're going to deploy a VM on Nutanix with a static IP from Infoblox. Again, by leveraging the scripts we've already written. So this is the entire script to do that. We can see first we import the Nutanix script and the Infoblox script. We get an IP from that using that Infoblox script, and then we plug the IP into our Nutanix script. So it becomes 3 lines of code to write that. So seeing it in action, it's the same deal here. We're going to get the next available IP from Infoblox, so it should be 12 in this case. And then we'll go look at Nutanix, see that we only have that Nutanix demo VM in this case. And we'll fire this off. And we can see that we have 10.11.89.12 as that IP and that our records were created. And we'll enter our credentials to Nutanix. Boom, we can see that that VM create request was sent off. Just one thing to note, that big block of text you see, that is an encoded part of that body. So that's why it's so long and gibberish, but it's part of that data we're sending over. All right, now if we go back, we'll check on Infoblox first. We'll give it a refresh. And yeah, we can see that the 10.11.89.12 IP now shows up in our IP in our IPAM view here. And now if we can see that that VM was created on Nutanix. And again, has the exact specs we expect, because we're not going in, clicking through a GUI, fat fingering things, making mistakes or anything like that. All right. So just to recap quickly, what did we just see in those demos? So on Nutanix, we created 2 VMs. On our Juniper switch, we configured 4 interfaces, but again, it could have been however many number we wanted to specify in that CSV. On AWS, we launched an EC2 instance. So that's 3 VMs across 2 platforms. And then on Infoblox, we allocated 2 static IPs and created 4 DNS records, right? 2 A records and 2 pointer records for reverse lookups. And so I went through and I added up the time of all those recordings, and going slow and checking our work, going through it, we did all that in less than 7 minutes. So I don't know about you guys, but I think that's a hell of a lot of work to get through in that period of time.